أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. My dear student, Assalamualaikum warahmatullahi taala wabarakatuh. So inshallah I will present to you our sixth chapter on hypothesis with means of samples. Now we will start looking at deeper analysis of your data rather than descriptive. Descriptive focuses on the frequencies and percentages especially for demographic background. What are the demographic background? Those are gender, education background, salary, location, anything that is closely related to the person, to your respondents. The next one is or we call it inferential statistic. Inferential statistics, we go to deeper analysis, we look into the connections, the differences, comparison among the variables involved in your study. There are many ways of looking at your data rather than the surface. It depends on your objective. You must remember that anything that you do or anything that you will have in your analysis should reflect the objective of your study. You don't simply analyze as you like without considering what are the objectives of your study. So you must really understand what does your study need, what does your research need. Otherwise, you will waste your time looking at unnecessary findings. Why is it unnecessary? Because it does not answer, or the findings do not answer your objectives accordingly. You must always look at the objectives and then look at the most suitable analysis for that particular objectives. For the hypothesis of means, we will look into the differences. We will test the differences. What is the differences, or what is the comparison you are looking at? So we will look into the basic principles of t-test, one sample t-test, independent sample t-test, paired sample t-test, one way ANOVA or analysis of variance. There are number of types for looking at differences. It depends on the objective of your study. ANOVA, it does not stop at ANOVA because we have ANCOVA. What do we mean by ANCOVA? Analysis of covariance. And then we also have MANOVA, multiple analysis of variances, and we also have MANCOVA, multi-analysis of covariances. The more variables you have in your study, the more variances involved. That's what we call multiple. Anyway, in this particular subject, we will only look into these 4 tests. I will not burden you with even more difficult tests because this is the basic. But the first thing first is to understand the principles of t-test. Okay, why do we need t-test? Why do we do t-test? Yeah? Among other objectives, why do we use t-test? Is to understand when to apply t-test. This is where your objectives are. And then we want to differentiate the three types of t-test. The one sample t-test, paired sample t-test, and independent sample of t-test. We run each t-test by manual calculation and SPSS, and then we interpret the results. Manual calculation. I believe that everyone is quite traumatic about calculation. Somehow, in this chapter, I will show you how that manual calculation is done. Since we have SPSS, I don't see why do you need to calculate them manually, because in SPSS you will have to key in all the data, and for this chapter, for this particular subjects, you have the dummy data. Based on that dummy data, you can do the analysis rather than manual calculation. I'm not saying that manual calculation is difficult. It depends. In my time, in those days, during my time, we did manual calculation, and we have no options. We have all the books in front of us. We have the calculator. We have no options but to calculate them manually, and still we solve the problem. We managed to get the answers. To the extent we had our exam with all manual calculation. So in nowadays technology, we are very lucky when we have that options. We have the system, we have the software that could help us in analyzing our data. So you don't think much about the manual calculation. Somehow we will learn how that manual calculation is done. What is the requirement? What is the requirement of t-test? The first one is you need the dependent variable in the category of interval or ratio data. That is your dependent. That dependent variable must be measured or must be in the category of interval or ratio data. Interval means range. When you have ranges from 1 to 10, 11 to 20, 21 to 30, and so forth. So what do you do is to make sure that the dependent variable in this category or ratio data, age for example, okay, so age is score or ratio. Some people call it ratio, some people call it score. And even in SPSS there's another term that cover ratio or score. And then we have independent variable. We have a dependent variable, and then we need another one called independent variable. This independent variable must in the category of nominal data. This nominal data not like usual nominal data, because it must have only two classes. If there are more than two classes, we cannot use in the t-test. I repeat, the t-test is only for independent variable which is nominal and have only two classes. Think of any data that provides only two answers, yes or no, male and female, tall and short, far and close, or short. Yeah, you don't look at other more, sorry, you cannot look at the data that has more classes, because that t-test itself cannot analyze those with more than two classes. So what is the assumption? The test variable, the test variable is normally distributed in each of the two population. So in this case, we can say, we want to look at dependent variable is what? Communication effectiveness. For example, you measure communication effectiveness, and then you want to look at the differences between male and female. And how do female and male and female differ with their communication effectiveness. So having these two with interval or ratio data and nominal data, the test analysis can be executed accordingly. Why do we have t-tests? Why do we need t-tests? The t-test assess whether the means of two groups are statistically different from each other. Is there any differences between the means of the two groups, male and female, for example? So when the means of communication effectiveness for female is higher than male, what does it mean? Is it significantly different? Not only the means score, which one is higher, but we also need the significant value. If the significant value is less than 0.05 or 0.01, only then we can say that there have significant differences. Or else, even though the means are different, no significant values, we can say that no differences. I know that there will be differences between the means, but as long as the p-value does not, or the p-value shows insignificant, then we can conclude that there is no differences between the groups. This analysis is appropriate whenever you want to compare the means of two groups. Remember about the two groups, you cannot have more than two groups or two classes. If there are more than two classes, you need to use another or other analysis. You cannot use t-test. There are three types of t-tests, as I mentioned much earlier. The first one is one sample t-test. The one sample t-test wishes to compare differences between sample mean and a test value. Put it at first. Put that understanding in this particular sentence, and then we will look into the details afterwards. Second one is paired or matched or dependent sample t-test. This is to compare mean differences between paired observation. What do we mean by paired? It can be man and woman, male and female, before and after taking medicine, for example. What else? It should be paired. It should be paired means it comes together before and after. What else? Man and woman. Perhaps Muslim and non-Muslims, for example. So independent sample t-test is to look at differences between two independent groups of means. Independent groups of means, this is what we need to identify, we need to define. What do we mean by independent groups of means? This is the symbols or the model that can explains better what do we mean by the three t-tests. Independent sample t-test, we look at group 1 and group 2. Group attending religious studies and group attending non-religious studies, for example. And paired sample t-test, pre and post. The same sample, they have gone through the process before and after taking medicine, for example. The three have similar intentions, which are the differences, but the way they are analyzed are different. So in order to understand each of them, you need to look at the whole picture. What are the similarities, what are the differences between the three types of t-test. From this point onwards, we will look into the details, and we will have to admit that they are different in many ways. Yeah, even though it sounds similar, like man and woman, male and female, or pre, post, before and after, and still these three types of t-tests have the three type of t-tests are different. Hypothesis testing. Yeah, when it comes to statistics, we need to have hypothesis. uh, we need the hypothesis. What do we mean by hypothesis? This is the pre-assumptions or the predictions of your data. 2 plus 2, what do you predict? Is 4. Then 2 plus 2 is 4 is your hypothesis. So if you're finding, say, and the other way around, 2 plus 2 is 5, for example, then you need to explain why does it not 4? Sorry, why is it not 4? Yeah, because 2 plus 2 should be 4, but now it is not 4, it's 5. So we have to look into the justification why the difference occur. Okay, look at this. The first one, of in every t-test, you need to have the hypothesis, null hypothesis and alternative hypothesis. What is the null hypothesis? The mean score, for example, is equivalent to 0. Is equivalent to 10, for example. Alternative saying that there is no differences from mean score to 10, for example. And then we need to calculate the test statistic t. Yeah? We need to look at the test statistic t with the symbol t, sum mean average, mean sum of average, sum average of mean, take away hypothesis, and then divided into Sx square root n. The third one is to determine critical value. When it comes to critical value, you must know the degree of freedom, which is equivalent to n take away 1. If your n is 10, then take away 1 is 9. Then we make a decision whether to reject the null hypothesis or fail to reject hypothesis. You look at the table, small table on the right, you can see the criteria. If the T calculation more than T critical, you will have to reject the null hypothesis. If the T calculation is more than T critical, then we fail to reject null hypothesis. The next one is significant T, and whether this is more than the alpha score or less than alpha score. We have to make decisions based on this figure, and then make conclusion. This is the part where you have to explain why your findings say such thing. Why is it not same to what you have a hypothesis before? Then you need to make the calculation. One sample t-test given the following. Given the following data on communication skills scores from a randomly selected sample of USIM students. You test the hypothesis that the sample mean is significantly different at 16 at 0.05 level of significance. 16. So the null hypothesis say that first there is significant difference, and then second the alternative hypothesis say there's no significant difference. So we have 15, 18, 16, 17, 19, 16, 18, 17, 16, 18, 17. Whenever you look at the data, we calculate how many n there, how many n, meaning how many respondents do we have here. So we calculate 2, 4, 6, 8, 10, 11. There are 11 respondents involved. This is where degree of freedom will come from. Okay, we have done the hypothesis. Now we need to calculate the test statistic. The first thing is to get the T. Okay, you need to get the mean sum of your data. Let's calculate the data. We have 11 respondents over there. Starts with 15 plus 18 plus 16 plus 17 plus 19 plus 16 plus 18 plus 17 plus 16 plus 18 plus 17 is 187. 187, in order to get the sum, the average, you need to divide with 11. What do you mean by 11? 11 is the number of your respondents. Oh my God. 187 divided into 11 is 17. 17. So the X with the underline on the top, it's 17. Take away U. So what is your hypothesis here? Is U is 16. So put 16 over there. Divide into Sx. How do we calculate Sx? We need to have 17, take away 16 and divide into 1.13 with the SX calculation. Okay, divide into 11, and then we need to divide 1.3 with 11 first. Okay, 0.118. 1.13 divided to 0.118. Oh, sorry, there is root square, so you have to root square 11 first, and then you divide 1.13 with root square 11. Only then you divide into the figure, so it goes to 2.94. The t value is 2.94. Okay, how to determine critical value? Remember the df, degree of freedom, and take away 1. 11 take away 1 is 10. So t a, the alpha, the critical value is 0.05. 10 equivalent to 2.228. Yeah, so that 2.228, yeah, what is the decision? We have to make decision that the t calculation 2.9412 is more than t critical value, which is 2.228. When the t calculation is more than t critical, we have to reject the null hypothesis. In conclusion, the sample mean is significantly different from 16 at 0.05 level of significance. When we have to reject because the null hypothesis say there's no difference. There's no difference with 16. So when your t calculation is more than t critical, meaning you need to reject the hypothesis. The sample mean is significantly different from 16 at 0.05 level of significance. And if you ask me where do we get the 2.228, it's actually from this table, the t distribution table. Those days when we have to calculate manually, this is the table that we need. Even when we have exams, the t distribution table will be attached. So the importance of this table is to look at the scores when you go to df, degree of freedom, and take away 11 is 10. So you go by that 10, go with the at significant value of 0.05, it is 2.228. So this is the, what do we mean by the t critical value. Okay, as simple as that. This is the next table at 0.0 depends at 0.25, 0.20 until 0.0005. So the df is on the left, so you just need to find the numbers of your df. Let's say if it is 10, then you go to df 10, and then under 0. If you go to 0.05, it is 1.812. Yeah, 11 at 0, even for 11 is different. This is it is 1.796. So it depends on how on GF itself. Okay, then you look at which point of significant value you are looking at. If it's less than 0.05 or 0.01, and these two are always used by researchers. So in SPSS, we will use you will use these tabs. Yeah? The first one, you click analyze, find the compare mean and choose one sample t-test. You move variable communication skills into the test variable. There's another box on the right. Okay, and then type the test value 16 and in the test value box, and then click OK, because one sample t-test is to look at how much differences, is there any differences by the mean score between the groups. So that's why you need to key in the test value eh, in the test value box. Click OK, then you will get the results. This is one of the table you will obtain from SPSS output. Yeah, you can see the significant total saying that there is significant differences because it's less than 0.05, and this is the mean differences, the T calculation, this is the GF, lower and upper. This is the example, another example. The national average for Moet was 75. That is a national or average. So you want to look at a school principal is interested to test that if his school achievement in Moet is higher than the national average, whether that school achievement more or less than 75. So the test of the hypothesis on differences at 0.01 level of significance. Summary of the school's Moet is presented as below. Okay, you get all the values for the calculation. Okay, we go by 75. Calculate the test statistic. You calculate, then you get the T calculation, which equals to 2.45. Determine the critical value. DF is n, take away 1 is 10. 11 take away 1 is 10. You go by the T table, the T distribution table. When your calculation is more than T critical, yeah, what can we say from these findings? That we have to reject the null hypothesis. The conclusion is the school mean is significantly higher than the national Moet average at 0.01 level of significance. Why is it higher? Because the T calculation is more than T critical value. Okay, this is the manual calculation. See, this is what? This is another example. Yeah, this is another example at 0.01. Okay, now you have the exercise. Given the following data information on communication skills scores from a randomly selected sample of USIM students, use the 5 steps hypothesis testing to test the hypothesis that the sample mean is significantly different at 51 as test value of this research. Test the hypothesis below at the alpha 0.05 level of significance and interpret the result. You have the table on the slide. You do yourself, try to calculate manually, because the more you do it, you do the exercise, you actually understand it well, how that the mean value is significant, or sorry, is different when it is significant. It is not different when there's no significant. You must understand that. So all the best with the calculation. We have done on the t-test, on the one sample t-test. We will continue with independent sample t-test and paired sample t-test. But this is the basic t-test that you have to do, you have to understand. But again, in SPSS, everything is solved. You don't have to key in you don't have to key in the DF, you don't have to key in the average, because it's all done by SPSS. So Alhamdulillah, thank you so much for being with me. See you next chapter. Assalamualaikum warahmatullahi taala wabarakatuh.